Hi, my name is Haley, and I'm a student at St. Martin's University. I'm here today to talk about Lambda expressions in coding. What is a Lambda expression? A Lambda expression is a small anonymous function in Python. It only has one expression, but can take any number of elements. These functions are concise, flexible, and functional. To set up your Lambda expression, you write the word Lambda and then your arguments. Your arguments would be variables such as a, b, or c. Then you write the expression that you want Python to execute. This could be addition, subtraction, multiplication, division, or you could use it to find something in a list of words. Here I have a list of examples for us to go through. Question 1 says, use Lambda to add 5 to argument a. So I'm going to create a new cell. We're going to make this function equal to the word add. Then, like the example, we're going to write Lambda a, because a is our argument, and add 5 to a, which would just be a plus 5. To print this function, we're going to write print add, which is equal to the function, and we'll let a equal 2. Five plus 2 equals 7, so we know this function ran correctly. Let's do a second one. We're going to write print add, and let's make it 100. So 100 plus 5. 100 plus 5 is equal to 105, so we know this function ran correctly. Question 2. Use Lambda to subtract 3 from argument b. We'll call this function sub to represent the word subtract. Then we're going to write Lambda b, because b is our argument. Then b minus 3. We're subtracting 3 from b. Once again, we'll write print, this time sub, and we'll let b equal 7. Seven minus 3 is equal to 4, so we know this function ran correctly. Let's try this one again. We'll write print sub 11. Eleven minus 3 is equal to 8, so we know this second trial ran correctly as well. Let's move on. Question 3. Use Lambda to multiply argument c by 8. We'll call this one m to represent the word multiply. M is equal to Lambda c. And then we want to multiply c by 8. So we're going to write c, an asterisk to represent multiplication, and then 8. Then we'll write print m for our function, and let's let c equal 4. 4 times 8 is 32, so we know this first trial ran correctly. This time, let's let c equal 15. Eight times 15 equals 120. This is true, so we know the second trial ran correctly. Let's add some more. Question 4. Use Lambda to add argument a to argument b and subtract c. Let's call this function x. X equals Lambda, and there are 3 arguments, a, b, and c, which we'd write as so. And then we want to add a and b, a plus b, and subtract c from that. Let's try this. We're going to print our function x, and then we write our numbers in the same order as the variables. So we're going to let a equal 8, b equal 7, and c equal 3. 8 plus 7 is equal to 15, and 15 minus 3 equals 12, so this trial ran correctly. Let's do this one more time. Print function x. This time we'll let a equal 18, b equal 6, and c equal 4. 18 plus 6 is equal to 24. 24 minus 4 equals 20, so trial 2 ran correctly. This time we're going to use a function definition. Question 5 says, write a function definition using Lambda that squares the number x. To write a function definition, we write def, and we're going to call our function squared because we're squaring a number. We want this function to return x squared, so we're going to write Lambda x, which is our argument, and then our expression is x double asterisk 2, which is the same as writing x squared. To make things easier, we're going to set the word square equal to our function squared. Then we're going to print square, and let's let x equal 3. 3 squared is 9, so we know this function ran correctly. Let's try it one more time. We're going to write print square 5. 5 squared is equal to 25, so we know the second trial ran correctly as well. In questions 6 and 7, we're going to use this list, numbers. Numbers contains the elements 1, 2, 3, 4, 5, 6, 7, and 8 in a list. Question 6 says, use filter and Lambda to find all even numbers in this list. We're going to create a new list, which we're going to call even. Then we're going to write filter, because it says to use filter. Then we'll do the same thing we've been doing. So Lambda x to represent the numbers, and then we want if x divided by 2 is exactly 0. This means that if the number is divisible by 2 with no remainder, it will be added to the list even. And we are taking these numbers out of the list numbers, so we add numbers at the end. Let's print our list. The numbers in the list even are 2, 4, 6, and 8. These are all even numbers, and they are all originally from the list numbers, so we know this function ran correctly. Question 7 says, use map and Lambda to add 3 to all the elements in numbers. We're going to call this list add 3, because that's what we're doing, which is going to be equal to our new list map. Then we're going to do the same thing, Lambda x, where you're adding 3 to x. And this is coming from the list numbers as well. Let's print our new list. Our new list contains 4, 5, 6, 7, 8, 9, 10, and 11. If you look at our original list, this is the same numbers with 3 added to each. Therefore, this function ran correctly. We have one more example, which uses a word. Question 8 says, use Lambda to get the length of a word. So we're going to do this like we did our first functions. We'll call this word length because we're finding the length of a word. Then we're going to write lambda word to represent the word we're going to use. And then to find the length of a word, we write len word. We'll try this out using print, word length, and our first word is going to be hello. Hello has 5 letters, and we got the number 5, so this function ran correctly. Let's try this one more time. Print word length, and let's do scissors. Scissors contains 8 letters, and we got the number 8, so this function ran correctly. Thank you for watching my video. I hope this was helpful.